Alright, yeah, that should fix that. I think I should be heard now. Um so guys, yeah, testing out on the new PC right now that I built yesterday. I didn't plan to stream on it today, but it was surprisingly easy to set up because all my stuff from OBS. So yeah, all the stuff came over from OBS, so didn't really have an issue there. So setting up the new PC wasn't that hard. I was able to do everything I needed to do. And I even got some new things to do. I still have some problems with the camera and the color because I realized like my jersey, when I go close, it's starting to, reflect. So I have to sort that out. On the wrong cover. Wrong cover. Fix the cover. It's supposed to be the next meme. It's supposed to be this one. Right. Yeah. Good. So yeah. Alright, so this one is CSEC paper 2. Ask me anything. Basically, whatever you want to know, I will answer tonight with the aid of my ST. So I have everything set up pretty normal, pretty good so far. Yeah, the new PC on right now. I am currently taking a risk and streaming in ultra low latency. So we'll see how this goes. So all those of y'all on the inside, don't forget to like the video, look for the little thumbs up there, and like it. I have one monitor on this side and the next monitor on that side. Final looking a little blurry. Let me see if I can sort out that blurriness there. Blurry webcam, why are you so blurry? Maybe it's because the focus is down. Alright, that might be a little better there. Alright, I'm feeling a little sharper. Just a tad. Alright, good. So the new PC is here and it's working. And I think yeah, some more tweaking to do on the camera because I'm still using my webcam. I ain't get the DSLR, so yeah. Yeah, so now I actually have my laptop separate. So I could I don't have to do everything from this guy anymore. Now this will just be for sharing the screen and teaching. And I have the ideal monitor set up and thing. All you see little pictures and thing in the background. But before that, we going to answer any question I have. I will answer it for you. This is, well, especially for people who doing JAN exams this week. But if they're not doing JAN exams and you have questions and you want to help you, yeah, no problem. I will help you. So let's begin. Hi, my name is Mr. Charles from makeITsimpleTT Educational Solutions, and I teach information technology. I have classes at the CSEC level, at the CAPE level, information technology classes for adults who want to learn technology, workshops, seminars for teachers, seminars for companies, anything that makes information technology simple for people who need to use it, we do it. All right, so welcome you all. Yeah, so let's see what we're going on here. All right, so I see oh, that's not before I start, I need to show y'all something because I was waiting to get this PC so bad to do one thing. You want to know what the one thing is? You want to know what the one thing is? I really wanted to be able to do this.
NANI?お前はもう死んでいる。
So now my stream gonna be like, yo, whenever we streaming and we doing questions, it's real kicks from now on. Like, real kicks. Anytime somebody says something stripping in the chat, I'll be like,
No! God, please, no! No! No!
oh wow, I can't wait for when exams start heat up. I'll just have them video memes rolling. Yeah. Yeah, if only seen my blurry, that's just my webcam. To sort out. I ain't really get time to sort out the webcam and configure the specs and thing on the new on your computer. And you see my jersey kind of shimmering sometimes. That's okay. But yeah. So when we see a paper, when we see a question on the specimen paper and the specimen paper wrong, guess what we'll tell them?
Lie again. Lie.
Alright, okay, cool. Alright, so there we go now. Person who asked that question, I still had to test out the chat because I kind of changed the layout of the chat too. But Jarrell Jacob, alright, Jarrell Jacob, you say you want to know how to do trace tables. Let's see if I could get you to understand trace tables pretty quickly. Alright, so there you go. Trace tables, right? Now I could flip my laptop on and all kind of thing and be like, I'll be able to write neater and all that stuff. Alright, so we're going to trace tables. Now when you're doing trace tables, your biggest problem is that you need to understand how the algorithm actually going first. So if you don't understand how the algorithm going first, then you wouldn't be able to trace what is happening. So I'll start with a real simple trace table. So let's say I have A is equal to 5, B is equal to 6, and then say C is equal to A plus B. If we also trace that out, then you would basically have to list all the variables I have. So we listen all the three variables that we have. We have a A, we have a B, and we have a C. How do I know that? Because I know that the A is one variable, B is one variable, C is one variable. So anytime you have a trace table, first thing you have to do is list all the variables that you have, right? So after we list all the variables that we have, you want to now check line by line to see what is happening. So on this first line here, A is changing to 5. So for A to change to 5, I have to put in the value that A changed to, which would be 5. And then good. So I finish with that line. When I reach this line now, B is 6. So I'm going to represent this line here with 6. And then when I reach this line now, C is equal to A plus B are going to represent whatever the value of A is and whatever the value of B is. So the value of A is 5, value of B is 6. So in actuality, what we're actually doing is adding 5 plus 6. When I add the 5 to the 6, the answer that I have inside here is going to get stored inside C. So 5 plus 6 is 11. So really and truly, the answer that goes inside C is 11. So I've traced it, that simple table there. All right. So we good there. So the person who asks what topics come for paper 2 and how many questions, they ask you everything that is possible in the syllabus, and you have 4 questions to answer. Alright, so that's basic trace tables there. Then you go to our next if trace table, right? So we're going for if trace table now. This is sequential. Let's do a selection trace table now. Alright, a selection trace table would be we had to ask the user. We'll say A is equal to 5, B is equal to 6, and then we want to now say if A is greater than B, then high is equal to A, else high is equal to B. Right? So with that simple layout there, now if we're going to trace through what is actually happening there, you are saying to yourself, all right, so now I have to answer the question based on what is happening, because if I do answer it based on what is happening, I'll do shipping this. So what we're going to do now, we have to draw the trace table, same layout, because we have three variables again. We have a A, you have a B, and you have a C. No, you don't have a C, sorry. You have high. Right, so you realize those are the three variables. Right? The three variables are A, B, and high. Don't mind it come up twice, right? So we inside there again. Let's go now with what we start off with. We start off with A is equal to 5. So we put 5 inside there. Next line now is B is equal to 6. So we want to take note of that. A is equal to 5, B is equal to 6, right? So you're taking the A is 5, B is 6. Now, we reach this part where we have to make the decision. The decision is A greater than B? And the answer to this question could either be yes or no. If the answer is yes, you're doing this one here. If the answer is no, you're doing this one here. So now we have to check to see what is inside A and inside B. Inside A is the number 5. Inside B is the number 6. So we're checking to see if 5 is greater than 6. Is 5 greater than 6? The answer that we're getting is no. So if the answer that we're getting is no, we are choosing this option here. So we'll set high to whatever was inside B. So therefore, high will end up becoming 6. That's how we trace that. Alright, follow me there. You got it up? Gerald, you asked the question, right? So you are to let me know if all okay, and if anybody else have any questions, ask while I wait. Alright, cool. So now we go into a loop now. So let me do a simple loop, which will be let's say 4C is equal to 1 to 10. Now 10 is too much. I'll do it at 5, right? 1 to 5 do. So 4C is 1 to 5 do. I want to do let's say A is equal to A plus 2. Alright, so I'll set up with A is equal to 0 here. And then B is equal to B multiplied by 2. So I'll set the B as, no. Let me change the question a little bit. Right, B is equal to 0, A is equal to 0. And I will say A is equal to C multiplied by C plus 2. And next one is C multiplied by 2. Right. And 4. Alright, so this is where trace tables will start to get a little bit more complicated, because you have to actually trace what is going on in a loop. So the first thing, as usual, always set up the trace table and line up what the variables are that you have. Always. So you start off, you have a A, you have a B, and you have a C. Some trace tables can get really, 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 really long, and then you have a lot of variables. But you don't want to miss any variables, right? So A, B, and C is what we have. So we're starting off here. Now this one we're going to do a little different, because now we're going to treat everything line by line. So we're going to deal with these two first. These two are two commands. I will set A as 0, B as 0. Right? So this is like the first. This is like the first set of instructions, first set of things that are going to take place. Next thing you want to do now is now we have to check to see what is going to happen when the loop starts. When the loop starts, what's going to happen is that this one here, sorry, let me change the color. this one here is going to be what C starts at. So that means we know that for sure that C will be 1 because it said 1, 2, 5. Really and truly, what C trying to do is to go from 1, then get to 2, then get to 3, then get to 4, and then eventually get to 5 and then stop. Right? So because we know that, we know C will start off at 1. So what happens when C is 1? Every single thing that's inside this box here is what is going to happen when C is equal to 1. Once it's between the 4 and the end 4, it's going to happen as long as the numbers are within the range that you have them at now. So we're starting off here. When C is 1, what's going to happen? We have 2 commands that we have to execute. We have to execute A is equal to C plus 2. So A is equal to C plus 2, which is 1 plus 2. So right now, C is 1, and 1 plus 2 will give me 3. That's the first loop, right? That's the first command. Then the second command now is going to be C multiplied by 2. So right now, C is 1. So C 1 multiplied by 2 will give me 2. And that now will deal with the whole first loop. So this is when C is 1. After C is 1 now, the next thing that's going to happen is what? C is going to change to what? Somebody tell me. What is C going to change to? C is going to change to 2. Alright, good. So C is going to change to 2. When the C changes to 2, we're going to put the 2 inside here. And then when we put the 2 inside here, we're going to now take 2 and use that inside here for the calculations. So the calculations now are going to change to whatever the new value of C is. So right now, C is at 2. So the question is now, what is going to happen when I run these commands the second time? Second time I run these commands now, A is going to be 2 plus 2. So A is going to change to the value of, which is C, plus 2. So A will change to 4, because 2 plus 2 is 4. Then B will be 2 multiplied by 2. So that will become 2 2s are 4. Right? So we have A running the second time, and then B going the second time. Cake. Right? All you don't know the drill. If you're on my channel and you get the answer correct and you're feeling good about yourself, you send the cake emoji. If you're not too sure, you ask a question. And if you are finding it too easy, or if you learn something new, send the scholar emoji. You need to know the emoji language on my chat, because that is what lets me know when the world is going good. So if you're learning something, scholar emoji, thanks. Right. Right, so now the third time now, the C is going to change to 3, because remember the goal of this thing was to go from 1 to 2 to 3 to 4 to 5. So we're going to take now the 3, and we're going to calculate what's going to happen now. So in the next loop now, we're dealing with it again, which is C plus 2. C is now 3, so 3 plus 2 will become 5. And C is 3. 3 by 2 will become 6. And that will go on like that. Then the loop will happen again. So right now, how much times we've looped? 3 times. So we're going for the fourth loop this time, 4. And on the fourth loop, we are going to now end up with C being 4. Right? So we're going to have 4 plus 2, which will become 6. And then we're going to have 4 by 2, which will become 8. Then the next thing now will be the final loop, which is the 5th one. Now, once we reach number 5, tell yourself that's the last time this loop is going to run. Right? So the last time the loop is going to run, it will be the 5th time. And now the C that we have is going to be a 5. So we're going to take this 5. And, what are we going to do the 5 by? I forget. Right, yeah. Right, so we are in the 5th loop. So now the 5th loop is going to be 5 plus 2. And 5 plus 5 by 2. So 5 plus 2 is 7, and 5 by 2 is 10. And now we know we are at the end, because once we reach this 5, we've reached our goal. Our goal was to go from 1 to 5. Did we go from 1 to 5? Yes, we did. So therefore, this trace table is finished. Do you have any questions? Where my other mods, boy? This is Jarvis right now. Chippish. I keep saying Jarvis, but it's really Jarvish. Jarvish. Yeah, dog. All right, so Jorel, any questions? What if do you have to have the end for? You don't have to have the end for all the time, but the end for kind of signifies where the block of the for loop is going to finish. If you do put the end for, you could kind of mix it up with whoever comes next. So if you have like if you do have the end for, and then you end up putting something like if coming right after, the if might be considered to be part of the for. But if you have end for, you'll know that, all right, this is the end of the for loop here, and this if that's starting here is something totally different. So that's the concept there. Nice. All right, so I'm gonna do one more trace table, and then y'all will tell me the answer for it, right? So I'm gonna show you what this try to give you for CSEC. So they'll give you a set total is equal to 0, and like say R total is equal to 0, and M total is equal to 0, and they will read from the user and let's say I had to get from 10 people, 4 C is equal to 1 to 5 do, and then it'll say print enter your fee, and then you'll read the fee, and then now they're going to say if fee is equal to 10, then our total is equal to our total plus fee. And then they'll have a else if fee is equal to 25, then M total is equal to M total plus fee, right? Right, so this will be a simple trace table that you would use. This kind of like a it closely resembles what SPA program looks like, right? Our SPA program will look very, very, very similar to this. So let's see what we have to do now. First thing we have to do is we have to find out all the variables we have. So let's find out the variables. We have R total here, we have M total here, we have a C, and we have a fee. All those are the variables. So the first thing you have to do, list out the variables. If you don't list out the variables on the top of the table, you'll end up in trouble after. So let's start with, I'll put it in the order that we got it. R total, M total, C, and fee. Okay, so let's try to make a trace table out of this. So we're going to trace it through now. We're going to take R total and M total start off at 0. So we leave that 0, 0. Do we know what C starts off as? No. So we just leave it blank. Do we know what fee starts off as? No, we leave it blank. Usually, when you write your program, they make it declare everything at the start. So usually you would have like C is equal to 0 and then fee is equal to 0, right? If that happens, then you just put zeros across the board. because initialization at the top is important because it sets everything to 0. So once we do that, then we want to now go on to the next line. The next line is going to be what? Tell me, what do you think? What is the first value that is going to be updated after we finish? We deal with these already. We dealt with this, we dealt with this, we dealt with that, and we dealt with that. What do we have to deal with now? Anybody? We had to deal with the C. Alright, so we had to deal with the C. And the C is going to change to 1 because it's a for loop. And the for loop here starts off at 1. Remember, the goal of the for loop is to go from 1 and loop all the way to 5. So you had 1, 2, 3, 4, and 5, right? That's the goal. But we start off at 1. So now once we start off at 1, we could enter into the for loop and follow the instructions. You see this one here? This instruction here? Print enter your fee. That has nothing to do with the trace table because there is no variable change taking place. So any line that doesn't have anything to do with a variable change, you don't have to record it in the trace table. You just have to know that it's there, right? So we read fee. When you read the fee now, there is a change taking place. We're going to read the fee. So let's assume the user puts in a number. What number they will put in? They could either put in 10 or 25. So give me a number. Let's say they put in, let's put in the first number. Anybody in the chat? Give me a number to put in. $10 or 25. Choose one now. While you're at it, click like, right? Then the likes match the amount of viewers. Thanks. Now, Jay, 0.6. You're wild anything. We're only taking numbers 10 or 25. Alright, only taking too long. So, I ask the user to put in a fee, and the person puts in the number 10, right? So when they put in the 10, the fee is going to now become 10 because that's what I got here, right here. That's why I asked the user to put in the 10. The user puts in the 10, and now I have to make a decision. My decision must be based around this. My decision must be check this if statement first. This if statement is now going to check to see if fee is equal to 10. What is the value I got for fee? 10. So good. So if fee is equal to 10, then I now have to follow this instruction that is put inside here. This instruction is what I'm going to follow because it came out true. This came out as true. So therefore, I'm not even going to check to see what else happening. Because this is true, I'm going to say, okay, now R total is equal to R total plus fee. What that means now is I'm looking at R total, which is 0, and I'm going to add it to the current fee, which is 10. So that means R total is equal to R total plus fee, so R total will change to 10. And then now, the else will never get to run, because once I get this first one to run, once this one say yes, then I good. I don't need to know what's going on with the else. So basically what's going to happen now is that the I didn't put the N4. The N4 is now going to loop back up and say, alright, cool. We had a successful run because we ended up choosing one of the options, which was this option here. So now, when we go back up to the for loop is going to be like, alright, what number are we on so far? Did we do 1 yet? Yes, we did 1. Alright, cool. Time for C to become 2. So the C now is going to become 2. When it becomes the 2, the next thing that we have to do is now go back into the loop and check to see what we're getting. So give me a number one time. Give me a number to choose. Give me, let me choose 25 this time, right? So let's say the person puts in a 25 this time. So we read the fee. When we read the fee, we're going to read, and we're going to get the number 25. When the 25 comes in, now we're now going to have to do the if statement. So I'll kind of rub off the stuff that we did from the last loop because we finished with that. So rubbing off that, Rubbing off this 10 here, rubbing off that, because we don't know if it's true yet. We're not doing that. We're not doing that either. Alright, so I'll try my best to be very neat here. Nice. Good. So now our new decision process is going to be the person put in 25. So now I had to ask myself, okay, if the new fee that I just got is 25, is 25 equal to 10? The answer is, what is the answer? The answer is no. So because it's no, I'm not going to do the yes, this one here, which is the yes option. I'm going to move on to the else part, which is this one here is the no. Because if it's not, then I have to do the else. And because it's not, I'm going to eventually choose this one. Because if the fee is 25, this one. Because the fee is 25, I'm going to choose this one because the number is 25. So now the question is 25 equal to 25? Yes, it is. So therefore, we're going to say M total is equal to M total plus fee. So what is M total? M total currently is 0. So we're going to take M total, which is 0, and add it to the fee that we just got, which is 25. So then this is going to go to 25. And as the second time the loop runs. How many more times is this loop going to run? It's going to run 3 more times. So it's going to end up going 2, 3, 4, 5, right? In your SBA, it's probably going to go like 10 times or 15 times, depending on whatever's going on. So because I know that, whatever number the person puts in, so the person might put in the number 10, then we'll just take the 10 and add it to the previous 10, and we'll get 20. Then if they put in 10 again, then we'll take the 10 and add it to the previous 20, and we'll end up getting 30. And if the person puts in 25 on the last run, then we'll take the 25 and add it to the last value of 25 because that's our M total, and then you'll end up getting 50 in the end. And that's how you do a trace table. So that's basically what your SBA trace table is going to look like. And then when you are done, you will walk out, you will hand it up to your teacher and then say, so what do you think about that? And then your teacher will be like this.
Oh my God! Wow!
Nice. So let's get my next question there. Anybody, you're doing Jan exams or you're doing IT or whatever you're doing in your life? Let me know. And I will answer. Nobody else have any questions? Everybody good? Hey, remember if you're good, you gotta send the scholar hatter. Jojo, Siwa, for CXC, do we have to answer in complete sentences? No, IT don't care. IT just what the answer. You don't have to write. The 2 things that the person uses would be, nope, you just write it in point form. First thing, second thing, bam, and you're good to go. Right, so while we at it, let me take the time to show you my website because apparently you'll need help with stuff. So watch this here. On my website, I have a section called videos. When you go to videos, you'll see CSEC IT videos. When you click on CSEC IT videos, you might get an ad because I have to eat, right? And when you scroll down here, you will see all the videos I have for CSEC. But there are sections. So there's the theory section. The theory section will have all the videos on theory. So if you want to know about how the syllabus is broken down, how much marks is for what, all that kind of stuff, you could find that there. If you want to know about the fundamentals of IT, which is the first part of the syllabus, CPU, ALU, OCR, OMR, them kind of thing, display outputs, wireless networks, barcode readers, system specifications, cloud storage, the World Wide Web, a detailed journey through the syllabus. All that is there. But then, if you want to learn about algorithms and problem solving, I have a whole set of videos that will give you pseudocode, control structures, pseudocode loops, pseudocode questions worked out live again, algorithms, flowcharts, trace tables, and truth tables. All are there. But then there's more. If you want to know how to do your SBA, I have videos for your SBA. I have videos working out the sample SBA that's in the syllabus. Then I have videos showing you how to do Microsoft Word stuff, website building, spreadsheets part 1, spreadsheets part 2, basic databases, advanced databases, algorithms, how to write an algorithm in Pascal, how to document it, how to do queries, complex queries. Wait, there's more. There's a next page. How to do flowcharts, how to do trace tables and all that stuff. And then wait, there's more. Multiple choice answers. I have multiple choice papers here. If you do these multiple choice papers, I guarantee you'll never get anything wrong on a multiple choice paper again once you pay attention to that. But wait, there's more. Paper 2 answers. I have paper 2 answers for all the past papers, all the way back to like 2015. And this year I'm going to finish out all the past papers so we can have everything there. So if you go to makeITsimpleTT.com/videos, you have everything there. That is gold. Right? So yeah, back to me. Alright, so let me see. Jojo, so for CSEC, so types of softwares, what topics come for paper 2 and how many questions? I told you all the topics come for paper 2 and you get 4 questions. Amira Stewart, yes, it are K papers on the website too. What you really telling yourself? Watch. When you go to videos, you have Cape IT Unit 1. Cape IT Unit 1. We have theory videos. We have multiple choice answers, paper 2 solutions, IA stuff. Yeah, we are thing. Been working hard. Like, work real hard on this thing. Right? So all the mods trying to link the page there. Well done. Keep trying. You'll get there. For some reason, when you type a page and thing, yeah. Alright, types of software, types of printer. Types of printer, I have a video for the types of printers. But let me go through the types of printers really quickly for Tizzy London. Tizzy London, types of printers. You have impact and non-impact. In impact, you have dot matrix. That basically hits the paper. Dot matrix, they take line off the syllabus. So dot matrix, basically, the key points are, there are pins that hit a ribbon. The ribbon is like carbon paper, right? So imagine like, the carbon paper that you would use when you're writing a receipt. And it's print out to the other side of the page, right? So the pins basically hit this ribbon. So I'll show you from the side, right? The side view will be like this. There will be these pins here, and then there's this kind of blue ribbon that's passed between it. And when the pin hits the ribbon, it hits the paper on the other side. I really can't draw that well, but it does happen like this, right? So a pin will hit here, and when a pin hit like that, it could hit in one line. All the pins will hit in one line, and then they will hit in our next line like that. And then a key gets imprinted on it. Like, that's how a dot matrix printer works, right? So when it hits the ribbon, it will print out on the other side. It's called an impact printer because it actually hits the paper for it to work. So that's the impact printer. Non-impact printers, now we have plenty non-impact printers. Non-impact printers could be anything from just now. Let's kind of get this guy across. Yeah, right. So non-impact printers, you have inkjet, which is like a dot matrix, but it squirts ink. Inkjets onto the paper. I have all this in a video that you could see on the website. I could literally just show you the video, but I mean, I want to get the live feeling. Right, it squirts ink onto the paper, and then you have a laser printer. which will be uses heat to fuse it, the ink, aka toner, to the paper. Alright, so when you think of a laser printer, think of, that project in school where you take the glue and you draw the glue on the Bristol board, and then you throw glitter dust, and then you shake up the glitter dust, and then the glitter ends up sticking to the glue, and then you throw off the rest of the glitter. Right, that's exactly what a laser printer does. It heats up certain parts of the paper, and then when the powder touches it, it sticks to it, and it just kind of roll it flat, right? After a laser, I think the next one on the syllabus is a thermal printer. Thermal printer is the one that you get in the groceries, right? So it uses chemically treated paper. Chemically treated paper. And when it gets hot, heat equals black mark. So the black mark that is get on this, like when you go to Price Mart or when you go to any grocery store, if you take your fingernail and you scratch it on the paper, it will get black because your fingernail creates heat. When it creates the heat, then it will be black. That's why after a while those bills tend to fade, because they lose their chemical composition. After thermal, after thermal, those are all the non-impact printers. Then they have the special printers. I think that's what the syllabus separates them at. Special printers will be microfilm. Just think big page to small page, to small film. So it's take a big page of like newspaper, and it will take a picture of it and then condense it into something that is 1/10th size. But you need a special machine to look at it. Right? Alright, then the next special printer is a plotter. Plotter is basically for billboards. Billboards and large signs, right? Large signs and architectural drawings. I'm not going to spell architectural because I really can't remember how to spell it right now. Architectural drawings. Yeah. And then the last one that they have on the syllabus, I think, is 3D printers, which uses resin. Resin is like, that's the plastic, right? To add layers on over time. Yeah. Right, so basically the resiners add layers over time. So a 3D printer basically just adds like, a piece there, and then put a piece there, and then put a piece there, and a piece there, put a piece there. And basically it creates a sculpture. So those will be the printers. Right, types of printers there. Right, I hope I answer your question. Who asked that question? Tizzy London. Tizzy, did I answer your question? Christopher, what are you trying to do me, boy? Validation checks. Reasonableness and consistency. Nice. Alright. Mr. Williams here is trying to cause trouble for me to explain this, right? So there are two types of check, validation check and verification check. So let me look at validation. Validation checks, some of them real easy to understand. Yeah, boy, Jarvis, just PC running smooth, quiet. I don't even know that it's here anymore. The thing just pumping. Like, let me show you the usage right now. How it looking? What's usage? We're only using like 7% of the CPU right now, and a mere 26% of the memory, 8 gigs out of the 31 gigs. Yeah. Hard drive, disk, Ethernet pumping. Well, look at the GPU doing some work. The reason the GPU doing some work is because I'm streaming. Yeah. So it's running at currently at 46%. Pretty much no issues. You want to see the You want to see the cause? All right, let me show you the cause. Let me show you the cause. Yeah, look all the cause there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, those guys just saying only they're just liming right now. They're like, oh, give me some work, please. Give me some work. If I was recording, yeah, you really causing much you see right now. Everything you see. If it was my laptop, and also the fan pelting speed. Cause it was like, dog, you really want me to do all this at the same time? I could do it, you know, but we had to ramp up the speed. So my laptop used to the fan used to go crazy, and I was just the fan noise used to like get me back. So yeah, that's why we have this PC. But anyhow, back to what I was explaining. Right. So we explained validation, right? So validation, I not even hearing the fan on the PC. Right, so validation usually is checking to see if the data is acceptable. So think of like validation. Like, you know, sometimes you just have to put on your clothes and your parents will watch you and be like, nope, that's not good enough, go and change. Right? Because the way that you're supposed to be dressed for that particular place, what you have on is considered to be invalid. So somebody checks it to make sure it meets a particular standard. And if it don't meet a particular standard, you get kicked out. Right? And a next example of validation would be like when you have to go and you had to apply for a job, and you apply for the job and they look at your grades and they be like, oh, nope, that person is not valid because they don't have enough passes or some kind of thing like that, and you're gone. And then that's validation. So validation is to check to see if the data is acceptable. So there are a few easy checks. So I'll do some easy ones just before I give you the difficult ones. The easiest one is a data type check. If I tell you the data type is supposed to be numbers, and you give me a 9, I will say yes, good, acceptable. But if you give me an A, it'll be like, nope, wrong, because A is not considered a number. So therefore, you'll fail the validation check of data type. The type of data will be wrong. The next type of check, which is the next easy one, is a range check. Range is cake, right? Because if I tell you that the number is supposed to be between 1, if I tell you the number is supposed to be 1 to 10, then I expect you to give me a number like 5. If you give me a 5, cool. If you give me a number like 11, I'll say no, that's outside the range. So you failed the range check. Now, there are 2 checks that are crazy. One is called reasonableness, which I think should be out of the syllabus for a long time now, and the next one is consistency. Those 2, I get vexed when they ask the question sometimes. So reasonableness will be like when I ask you, I could ask you, how many siblings do you have? And let me say you come and put in that, okay, you have 15 siblings. The reasonableness check now will say, nah, that's unreasonable. Therefore, that kind of weird. We had to not accept that, or we have to kind of flag it. So you kind of flag the information to say, nah, that can't be right. But really and truly, it's possible that you could have 15 siblings, because there are people out there who have 15 siblings. So a reasonableness check is always check to see if something is within reason. But who decides what reason is? So whenever you get a question that asks you for a reasonableness check, usually you have to try to think about things that are way out there or impossible. So if I ask you how many siblings I have, I should set the upper limit to 50, right? If you fill out a form and you say that you have 50 siblings, then it's probably
The lie again. Lie.
Yeah, it's probably that, right? So reasonableness check is usually those things that things don't add up. Consistency check now is basically when you put two pieces of data in, they check them against each other. So if you put your birthday is the first of the first 2010 as your DOB, date of birth, right? So you fill out the date of birth field, and the date of birth field say that. And then you put your age as 30. Then what's going to happen is that the consistency check will say, hey, this is not consistent with that. So that is inconsistent. So this is usually straightforward, where, you're just checking one date against something else. That's okay. But there are times when inconsistency checks could be something like, let's say you have a field to put in your nationality. And you put in your nationality as Trinidadian. Cool. And then you have a next field that says country of birth. And you put the country of birth as Nigeria. Then now, inconsistency check is going to watch these two and be like, hey. The person put in their nationality as Trinidadian, but they said that their country of birth is from Nigeria. What just happened there? And then they will pull you in a dark room and ask you for your passport. Then you probably get deported. Yeah. So that's consistency, inconsistency checks. And all that falls under a particular type of check called validation. Alright? So they could watch it there. I'll zoom out a little bit for you to see. Nice. So, for those of y'all, any of y'all here doing IT in this week, Jan IT? Anybody doing January IT here? Alright, if you're doing Jan IT, then I have crash courses on my YouTube channel. So I'm going to open up the crash courses. Actually, I'm going to open it up right now. And that will be available until the exam. You're welcome. Don't worry. You'll thank me later. Crash Course 2020. This crash course was my first crash course ever. It was epic. And if anybody is smart enough, they would watch this crash course. Edit, and let's make the videos live. How do I do this again? Wow. It's so long since I do that. Okay, right here. Whoa, wrong, no bad. Oh, that's when I used to sit down by the what's called this thing? The shelf. Yeah. So once our crash course goes live, you could watch it on YouTube for the whole week, and then I'll take it back down again. But if you want to know anything else, as I said, the website is the place to be. If you go on my website, I'm telling you, you could get one in IT just from watching all these videos, because I cover like almost everything that you could possibly cover. It's just that if you have the drive or the desire to do it. Because there are some people who had no teacher last year and all they did was watch the videos I had and they get one. So what I will tell you, boy, you can do it. You can do it. All right. So everybody else, I am logging out now. Thanks. I will see you in 5 minutes for ComSci. Yeah. So our ComSci live coming up after this. Remember, every every Sunday night. Check me. Don't forget to follow on Instagram, follow on TikTok, and share the love with all the people who need IT. And we go on there. Bye-bye.